Okay, this is basically what you need to remember when you are doing the mole calculation. Okay, how do you calculate mass? Mass is mole times the AR, the MR. How do you calculate mole? Mole is mass divided by AR or MR. 1 mole of any substance, 6 times 10 to the power 23 particles. Again, these particles can mean atom, molecule, ion, depending on what kind of substance is it. If let's say 1 mole of copper, it would have 6 times 10 to the power 23 copper atoms, because copper exists, copper is a metal, all metal exists in atoms. Okay, 1 mole of any gas occupies 24 dm cube at room temperature and pressure. And we have to remember 1 dm cube is 1000 cm cube. Basically 1 dm is 10 cm. That's why 1 dm cube is 1000 cm cube. Now let's look at this example. These 3 balloons, they look, the balloon, the size of the balloon look the same. That means that the volume of the gases inside the different gases have the same volume. So if the balloons are filled with the same volume of 3 different gases at room temperature, what it means is that all 3 balloons, they have the same number of mole, okay? And it also means that they have the same number of particles. So same volume means same number of mole. Same number of mole means same number of particles, because 1 mole of any substance would occupy 6 times 10 to the power 23 of the particles. If the balloon are filled with the same mass of different gases, if let's say the 3 different gases have the same mass each, it means that all 3 balloons have a different number of moles. Different number of moles, that means different number of particles. So same volume and same mass, they can mean very different things. Okay, percentage composition of the compounds. So find the percentage composition. So percentage composition of a compound, you can actually calculate it using this formula. Number of atoms of the element in the formula times the AR divided by the MR of the compound. So for example, percentage composition of hydrogen in the water. You need to know the formula for water. The formula of water is H2O. So it has 2H. So find out the 2H, the MR, which is 2 times 1. And then find out, and then over 18. 18 is basically the MR for H2O. So 2 over 18 times 100, 11.1, 3 SF. How about this? Find the percentage composition of water in a copper 2 sulfate crystal. Okay, so this dot means plus in chemistry. 5H2O. That means this is a crystal, and this crystal has 5 mole of water inside. So in order to find the percentage composition of water, the numerator has to be 5H2O. Okay, 5 times 18. 18 is the MR for H2O divided by the MR for the whole thing. So the MR of the whole thing is 250. So you get 36.03 SF. Okay, percentage composition, no problem. Okay, the next thing is molecular formula and empirical formula. So this is a complete definition for molecular formula and empirical formula. Basically, empirical formula is the simplest formula. So for example, this one, molecular formula that shows the actual number of atoms. Actual number of atoms in this case will be 6, 12, and 6. Actual number of atoms of what? Of each element. So that means 6 carbon, 12 hydrogen, 6 oxygen. So it shows the actual number of atoms of each element in the compound. Empirical formula would be simplest ratio of atoms of each element. So each element, the ratio of the number of atoms must be the simplest. So 6, 12, 6, all these are 6, 12, and 6 can be, all these 3 numbers can be divided by 6. So 6 divided by 6, 1. 12 divided by 6, 2. 6 divided by 6, 1. That's why you get 1, 2, 1 here. Now some compound have the same molecular formula and empirical formula. For example, carbon dioxide. So carbon dioxide, the ratio of the number of atoms of carbon and oxygen is 1:2. 1:2 is the simplest already. That is why empirical formula is 1:2 as well, CO2. But for hydrogen peroxide, H2O2, so the ratio of the number of atoms of each element of hydrogen and carbon, hydrogen and oxygen is 2:2. 2:2 can be simplified to 1:1. That is why the molecular formula is different from the empirical formula. Okay, the rest of the mind map it belongs to the pure chem. Okay, concentration of the solution. So usually when we look at concentration, we look at the amount of solute over the volume of the solvent. In most cases, the solvent is water, and the volume of the solvent has to be in dm cube. Okay, so there are two units of concentration of solution. One is gram per dm cube, the other one is mole per dm cube. Now, one thing to take note, this dm cube is the volume of the solvent, which in most cases is the liquid. This dm cube. Now, this dm cube is different from this one. This dm cube is the volume of a gas. Okay, so do not mix up. So this 24 dm cube, you can only use it for volume of gas. This is the volume of gas, not volume of liquid. So do not mix up between these two. So the concentration of solution can be in gram per dm cube or can be in mole per dm cube. Mole per dm cube also known as molar concentration. Gram per dm cube and mole per dm cube, actually they can be interconverted. They are interrelated. If you look at these two units, the only difference is the numerator. The numerator is gram and mole. So gram can be changed in mole. How? Look at the triangle. So the triangle says that gram, or the mass, if you divide it by the mR, okay, the mass in gram, if you divide it by the mR, you can get the mole. And likewise, if you want to change a mole per dm cube to a gram per dm cube, all you need to do is multiply the mR. So gram per dm cube can be changed to mole per dm cube, and mole per dm cube can be changed to gram per dm cube. So how do you change gram per dm cube to mole per dm cube? Divided by mR. Likewise, mole per dm cube to gram per dm cube times mR. Okay. Now, how do you increase the concentration of the solution? You can either increase the amount of solute while keeping the amount of solvent or the volume of solvent constant, or you can decrease the volume of solvent while keeping the amount of solute constant. Okay, there is one example here. 73 gram of hydrogen chloride. Now, this hydrogen chloride is actually a gas. It's a gas at room temperature and pressure. If you dissolve hydrogen chloride in water, you get hydrochloric acid. So the question now is calculate the concentration in mole per dm cube. So in gram per dm cube. So gram 73 divided by 500 cm cube, change it to dm cube, which is 0.5. Okay, so 73 gram divided by 0.5 dm cube, you get the concentration in gram per dm cube. Molar concentration, what is the meaning of molar concentration? It's the concentration in mole per dm cube. Concentration in mole per dm cube. So all you need to find is to find the number of mole, find the volume in dm cube, and then take the ratio. So the number of mole, hydrogen chloride, which is the mass divided by the mR, you get 2. Molar concentration, 2 divided by 0.5. And then how many mole of HCl are there in 100 cm cube of the solution? So from B, you found out that the concentration, the molar concentration is 4 mole per dm cube. 4 mole per dm cube means 4 mole in 1 dm cube. And the question wants in 100 cm cube. 100 cm cube is 0.1 dm cube, because 100 divided by 1000. So in 0.1 dm cube, this will be 0.4, because 1 change to 0.1 have to be divided by 10. So 4 divided by 10, you get 0.4. So hence 0.4 mole of HCl in 100 cm cube of the solution. So this part, it's about concentration.